So we're going to talk about the vertical translation of a function. So we're going to use this notation f of x plus k, and k is the value that we are either going to translate up or down. So it's the number of units that the function will shift up or down. And we'll be able to see it very clearly on the graph, but I also want to go over an example of the algebra. Well, here we are. We're going to talk about vertical translation of a function. And our example is going to be, a specific example, is f of x equals x squared. And what we want to do to that is we want to go up 2. So for one example, we're going to go up 2, and for the second example, we're going to go down 2. I want you to visualize this function as f of x is just going to be the parent function, so it looks something like that. And basically, what we're going to do is take f of x, and we're going to add k to it. We are going to replace k with the number 2, because k equals 2. And let's call that our new function. We're going to say y equals f of x plus 2, which is a vertical translation up 2 of f of x. So we are going to rewrite that then. Y equals, and we'll write down what f of x is, which is x squared, and then we're going to finish it by adding 2. So that's basically how we do our vertical translation with algebra. What it looks like here on the graph is that we are taking this point and all of the points, and we are moving up 2. So I want you to visualize that you're just taking the origin, the point on the origin of that function, and moving that up 2, and all the other points are moving up 2 points as well. So the new function, the green one, right here, this new function that's written right there, that is the function x squared plus 2. And the black one is still x squared. It's f of x equals x squared. All right, so for the second part, actually, why don't we use red? We'll use red for this. We're going to go down 2. All right, so we're going to take the original function f of x, and we're going to go down 2. That means we're going to subtract 2 from it. And let's just call that the function z. We can call it whatever we want, whatever function it is. It's a new one. It's a translation of f of x. So we're going to do a substitution wherever that f of x is, right here. We're going to substitute it with x squared. So we're going to write an x squared minus 2 equals z. And this is our translation, our translated function. So again, if we were to draw a graph, the original graph of f of x looks like this, our parent function, right? That's just f of x. But we are going to shift the whole function down 2. It's not the most beautiful drawing. Down 2. So all of the points are going to be moving down 2, all of them, to look like this new graph, which we'll call z, our red graph. And again, the key point here that I want you to remember is pick something to latch on of the function you're trying to translate. And I picked the origin, and I'm moving down 2 points, and this is my new kind of anchor for the new function right here. That helps. So lastly, I did a rough sketch, but if we were to graph this on Desmos.com, we would get 2 graphs that look just like this. Again, we went up 2 and down 2, and our f of x is our black graph right here. That's the one that we started with, and we moved up 2.2 right here and down 2 right here. And again, focus on the anchor point when you're redrawing the graph. If you move the anchor point down or up or left or right, you can just shift the whole graph down or up or left or right. But it really helps to know that anchor point.